thank you everybody for coming along. And yes, good morning from Australia. It's great to be able to join you. Um, it's also pretty good to have gone through the introductions, and I don't have to describe DataStax this time around. Although I am excited to show a bit of what we have and what helps build AI agents as we go through this talk. I also love these things to be interactive. I don't think I can see the chat, but if you do have questions at any point, do feel free to interrupt. You know, like there's not that many of us here. We're not messing with the flow for a lot of people. So please get involved and ask questions as we go. I'd absolutely love that. So cool. Quick introduction to myself, though. I'm a developer relations engineer at DataStax. You can find me all over the internet as Phil Nash, including, we've mentioned LinkedIn a few times. I'm there on LinkedIn as well. Or if it's hard to type any of that, just go to philnash.sh/links. You can find all sorts of links to me. I am based in Australia, but I do enjoy speaking at and attending events all over the place. So it's an absolute pleasure to be virtually in Portland today. Thank you for having me. So 2025 is the year of agents. I did not keep up with all the build announcements last week because there was also, I try and keep up with Google, but I was also at another event myself. And so I have no idea what's going on, but I'm absolutely certain there was a bunch of things said about agents as well as just extra models added to Azure. But building agents is absolutely, it's become the superpower, I think, of developers that we have in our hands, because many of us, I'm sure, are users of all of the available kind of AI tools right now, from your ChatGPTs, your Claudes, to even code building things like Cursor or Windsurf. We're currently users of those and seeing kind of some of the magic that can be created from models that have agency, that are able to impact upon the world. But I don't think we just want to be users. Like, when we have the tools at our hands to actually build on top of these things, we want to be builders of those things. And that's why today I want to take you through building a kind of a basic agent that is going to show how all these things work under the hood, whilst also actually coming up with some quite powerful kind of responses in not that many lines of code. So I will be live coding this. So I hope you've all got fingers crossed for me. I've practiced this, so I expect it to work, but you never can tell. So let's have a quick look at an application. It is a super simple application that I'm running. I'm running a sort of command line application, and do shout out if you can't read any of this. But just down in the bottom terminal, I've got just a command line application that if I say hello to, will echo hello back. So this is currently the world's worst agent. It does nothing except echoing things. So I've called it echo agent, and indeed it just responds with echo. And we're going to build upon this application to see kind of the various states of chatbot up to agent that we're able to create today with, as I said, just a few lines of code. So each time we'll be, so I'm working in JavaScript. Apologize if that's not a language that you tend to use, but the underlying theory of all this is all the same, regardless of the programming language. But I'm going to do it in JavaScript because that's just where I'm comfortable, I'm afraid. But anyway, everything works around this like agent class here, and so we'll be building new agent classes over the course of this in order to keep upgrading the powers and capabilities. The rest is just doing a command line interface. We get the user input there. We give it to the agent somewhere down here. There we go. We just wait for the agent to respond. That's about the most complicated thing that goes on in this file. That's all that matters. And then we've got our echo agent, which we're going to upgrade. So how are we going to do that? Well, let's talk about agents. And let's talk a little bit about what agents are, because I think everybody starts with everybody has different views on what agents are, kind of thing. I'm not going to try and define it myself. Other smarter people have written down things or said things in front of lots of other people first, so I'm just going to rely on those. First up is a paper from Google, which was released in September last year, which is fairly early on in kind of a lot of this ability to build agent kind of side of things, at least with the I'll come back to what I mean from that. Anyway, there was a paper from Google last year where they said a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. So some key things there. It needs to achieve a goal It needs to be able to observe the world. It needs to be able to act upon it. Goals, observations, and acting. And then meanwhile, Jensen Huang of NVIDIA, at the start of this year at his CES keynote said an agent is an AI that can perceive, reason, plan, and act. And again, perceive, these kind of match up, right? Perceive and observe the world. Reason and plan is kind of attempt to achieve a goal. And then act is to act upon the world using the tools that they have. So I think these are good definitions. We'll see a little bit more about what that means in a bit. The Google paper also decided to define a tool as something that bridges the gap between the agent's internal capabilities and the external world. And I think this is really important because models, generative AI models, large language models are capable of generating text, and that's all they can do. They're very good at it, and I love what they do with it, but that is all that they can do. And so we need to be able to give them the capabilities to do other stuff. And so when we talk about like a tool that bridges the gap like this, it's really just a function that they can call from in our application to go and achieve more things, to call on APIs or to do calculations or whatever. It is important to note that, again, because the models only generate text, all they can do is effectively ask to call those tools. And the calling of the tool is on our application. It's we have to hook that up in order to happen. They're not doing it themselves necessarily. Some of the models make available some tools internally as well, but like for the purposes of this, we're building our own tools and we're going to give them to our agents. And so this little diagram comes from that Google paper and kind of wraps up what a simple idea of an agent is, in which we have the model down at the bottom here in pink, but a lot of the real work goes in the orchestration, and that's building the application around the model in order to let it work with models and work with tools and do other stuff. And so we have the profile, goals, and instructions, and by that is kind of giving the model its goal to achieve. Comes as part of the system instructions and then the user prompt. Models like this need memory. They need to know what they've been asked. They need to know what their goal is and remember that in order to continue to work out if they've achieved it yet. And this diagram calls out short-term and long-term memory. I'm actually only going to deal with short-term memory pretty much in this example, but long-term memory is important for agents that you may want to interact with over a longer period of time. And then the model-based reasoning and planning, that I actually don't think that necessarily lies in orchestration. It is part of the model to me that allows it to, or both ask to use tools and functions, but also understand that that the response has been given for that. And then on the far right-hand side, we then get tools, which can just be anything, any kind of function that your application can call, we can hand to a model in order to give it the opportunity to do so. Don't give it, the keys to everything you've got, but give it targeted things that you want to achieve. It's also important to consider that not all models can perform function calling specifically. So there's actually a history of this, right? Where back when we started using generative AI large language models, they could just generate text and you could give it examples such as example JSON content to return. And most of the time, being non-determinative, most of the time it was capable of generating a matching JSON document. And that was useful to be able to use in an application. But it was also a bit rough. And so things improved over time. We got structured outputs, particularly OpenAI has a very strong structured output mode, which you give it a JSON schema document, and it promises to return results that fit that schema, which is really useful. And that then leads on to function calling, in which we give tools that have JSON schema documents which describe their inputs, and when a model then wants to call one of those tools, it returns the function, the tool it wants to use, and the structured kind of data that you're going to put into it. But not all models can do that. It's been a growth up until now. when we do give a model tools, they are we have to describe them. We give them names, we give them descriptions, we name our parameters, we give descriptions to the parameters, and all of that is effectively prompt engineering. It's all part of how we describe tools to a model, and the better you describe them, the more a model knows how and when it should be able to use them. And so the tool names and descriptions are super important. Agent execution time may increase. I've spent a lot of time working with DataStax stuff doing kind of RAG bots, which are pretty much a case of take user input, search a database for relevant results, put that all together, send it off to a model and get a response from that, send that back to the user. And so that very linear kind of flow is understandable in terms of its performance. However, an agent sends itself in a loop, basically, trying to see, have I answered the question yet? If not, can I use a tool to answer that question? I've got a diagram for that loop in a bit, but it's important to know that execution times may increase for agents. And so whilst my example here today is going to be chat, just because that's a nice and easy way to interact with it, it's maybe not the most ideal setting for agents if you have a lot of work for it to do. Chat is not as immediate if the agent is set off around a loop and doing a lot of stuff. And then finally, you don't always need an agent. Like if your problem can be solved with a RAG-based chatbot, then use that. It's cheaper, it's quicker, it'll be more efficient. But if you think that you need an agent that's going to change things in the world, then let's carry on. So basic generation. I'm going to jump out of the slides again, and we're going to create ourselves a new agent. But first, I'm just going to point out that today we are using Azure AI Foundry. And that's a slightly new name for it, but that's I'm not big into Azure myself, I'll be honest. But what I've done is gone into Azure AI Foundry and create myself a new project. And inside of that project, I've got endpoints and API keys, which is all very cool. And this is where you can kind of set up the models that you have access to. So there's the model catalog here, which gives you access to all of the fun, fancy models. So as we were mentioning earlier, Grok 3 is now now available since build, as well as other kind of brand new things. There's new Phi models. There's GPT image models. There's so much stuff going on here. I also appreciate this leaderboard down here, just kind of giving you like, what's the best, what's the quickest, what's the cheapest. And so we're actually going to be using GPT 4.1 mini here. Again, that's for me, it's a fast one. It doesn't cost too much, and it's very good at picking tools. It's a tool using model. And so I added that to my deployment. So if I go to, just to point out, we'll use this OpenAI, Azure OpenAI endpoint later, and as well as the API key that we have at the top there. And where's it gone to? Do you know what? I always forget this. I lose my endpoints. There they are. So I've already deployed this GPT 4.1 mini model, and it's available for me to use already. It does mean it's also available to play with in the playground, which is great. So we can go and kind of interact with it over here. Hello. And it's just, yeah, how can I assist you today? The playground is really useful for playing around with some of the system parameters and stuff, such as its temperature, its top P. Ooh, that could, top temperature, top P. I like this. Write me a story about a gnome in Australia. When you turn that temperature and top P right up, it's the sort of thing that ends up going off the rails, and I love when it does that. Disappointingly enough, it didn't quite do so. Yeah, I've toned temperature up on things recently, and I just love that it kind of ends up just spewing out just ridiculous stuff, which is great fun. Apparently, this is going to be fairly chill about the whole thing. Anyway, the chat playground is really useful to kind of just interact and play with the models that you've deployed, but rather than just play with them in that, let's go play with them in our application instead. And so I'm going to take this echo agent. I'm actually just going to copy. I like to keep all the things lying around and just change that to call it basic agent. These aren't really agents. It's a bit of a cheat. But the first thing I'm going to do is just import a couple of things that I had set up already. And this client is just a Azure OpenAI client. So it's actually using the OpenAI node module in this case. But we call out the Azure OpenAI class to create the client in this case, just because Azure has slightly tweaked the APIs from OpenAI. And so you can't use the just normal OpenAI client. There is a special Azure OpenAI client, and we are authenticating that with its API key, API version, endpoint, and deployment, all from the Azure dashboard there. And so having done that, I'm just going to create a constructor here, which takes in the options. The options are things like the temperature and some other bits. And so we're just going to, that merge options thing just gives me a way to merge all the things and give me some good defaults. So I have GPT 4.1 mini as my default model. We've got a temperature. I've set it to 0.2 for right now to keep it rational. And the system instruction, a very simple, you're a helpful assistant system instruction right now. And then we need to change the respond. We can't just echo back to things. And so in this case, we're going to use the client to make a chat completion and return the text from that. So I have Copilot trying to help me out here, but it's not very helpful at times. So we'll see how that goes for me. So we're going to completion using the OpenAI chat completions create endpoint. And to that, we pass a model. We pass some, it's helpful, but not quite helpful enough. We're going to pass some messages. The first one is actually the system prompt, but OpenAI changed the name of that from system to developer at one point, which I think is nice, calls out our role in this. And so we send in a system instruction there, currently just your helpful assistant. And then we send in a second message from the user, which is their incoming prompt. We set the temperature, that's useful for later. And then I'm going to get a message out of the response. So, the message is, you get a bunch of choices, but the choices array is normally just one long right now. I think you can opt to have more, but it takes longer and it requires more tokens. But so I get the message out of there and I can return the message content. And so that's all we need to do to update this from our Echo agent to our basic agent to use the Azure OpenAI client to complete a chat. And if I go and change from Echo agent to basic agent, the thing restarts and I can say hello to it. And now we're going off to the model itself. How can I assist you today? Cool. And this is very basic because actually it has like very little going on, so I can say, tell me a quick story, and it will go right out. A quick story about something going on in a village nestled between rolling hills. Lovely.
So quick question, Phil, before we move forward.
Please.
Question from the chat.
Yeah.
Copilot Studio is similar enough regarding feature and function and workflow to Azure AI Foundry, yes or no? And I'm happy to help answer that question and get your feedback on it.
That'd be great, because I'm not sure what Copilot Studio is. Oh,
yes.
No, I do know what that is. Yes. I've never used Copilot Studio. If you have, go with your answer first.
Sure. So Copilot Studio is the low-code Power Platform way of building agents. And they've made it super easy, right? Like, hey, you like add knowledge, you spin up an agent, then you can publish it to a channel. Now, AI Foundry and Copilot Studio are very different. AI Foundry is the pro code environment where you can build, you can evaluate, you can deploy. Now, AI Foundry and Copilot Studio are also connected. You can bring knowledge or what's called indexes and make them available to the agents you build in Copilot Studio via AI Foundry. And you can also create and orchestrate agents that you've built from AI Foundry to Copilot Studio. But AI Foundry serves a much different purpose than Copilot Studio.
Yeah.
Robert, does that help? Oh, go ahead.
Yes, that's perfect. That's awesome, actually. Very nice to know.
Yeah, and I'll note that, AI Foundry has its own agent section here as well, which also allows you to connect up knowledge and actions and other agents. And the actions specifically you can make out of particularly custom functions or Azure functions with code, as well as your Azure Logic Apps and other tools. So this being the pro code side of things is certainly where I feel more comfortable. But you can go create agents here. I just am going to do mine in code today, just because I get excited about that kind of thing.
Yes, yes, and if you are interested in more Copilot Studio stuff, that's where our Power Platform user group, like, great place where we have tons of Copilot Studio content coming.
Awesome. Thanks, Greg.
Yeah.
I just wanted to point out, we mentioned Langflow earlier. That is DataStax open source generative AI builder, which I can show you a way of building exactly the same agent or exactly the same bot in this case in Langflow, because it is it's a drag and drop builder. And in this case, we can bring in a model from Azure OpenAI, set it up with all our same endpoint deployment names and API keys and API version. And then it kind of lays itself out, hopefully, as you'd expect. So we have a chat input, a prompt here, which actually is serving the system message, and a chat output. And this is just another playground in which you can play around and have a chat with your model whilst building it up from nothing, or not from nothing, I guess. But like this is our very basic kind of version. And because there's a whole load of other components you can just kind of drag and drop and play around with, it's really easy to experiment with here without having to write a bunch of code or just hook things up inside a web platform. I'm currently using desktop Langflow. You can download a desktop version of it, but also it's an open source Python application that you can pip install Langflow and play around with as well.
Bill, if you don't mind, I would love to add my 2 cents on this. I think Langflow almost is like a good middleware between, hey, I have something low code in Copilot Studio, which is very much abstracted away from me, and I'm just clicking buttons, to Azure AI Foundry, like pretty much full on pro code. Langflow kind of there in the middle. And what I love about Langflow is you can actually see what's going on, right? And sometimes it's hard to visualize all the things that you've brought to an agent or a RAG app, without having a visualization IDE like that.
Absolutely. And one of my favorite parts about it is also simply that the code is also just kind of there under the hood as well. I'm never going to get away from the code, but you can edit and update those components by hand as well if you ever need to. But being able to see what's flowing through your application is super useful. And so that's our basic agent in both in code, just not that much to it, but also our basic agent in Langflow. But we'll go back to the slides and realize that this basic generation is cool, but it doesn't have any of our bits that we need for our thing yet right now. No memory and no tools. In fact, if I go back to our bot just briefly and just tell it my name is Phil. It's really happy to hear it normally. Hello, how can I assist you today? But if I ask, what is my name? It does not know because it just has simply no memory. It's just generating stuff. And so let's go and build basic chat instead. This basic chat takes us just a little bit further. So I'm going to copy again my basic agent from there to a new one and call it chat agent. And in this case, chat is actually, it's also just prompt engineering in a way. Chat is just keeping a list of the messages that the bot has already seen and playing it back to it every single time. So in this case, I'm going to just create our list of messages here. I'm going to take the system message that we used earlier to initiate that with. And then instead of passing just a new list of messages, I'm going to pass the messages, from in the Alone Copilot, from the that we're storing. And so each time we ask to respond, I'm going to take the messages and push in a new one from the user and respond using that. And at the end of it, we actually have to ensure that we keep all the response messages from the bot so it knows what it said back as well. Message, there we go, yes. And so each time we ask to respond, we're going to push in the message from the user. We're going to get the response based on all the past messages, and then we're going to store that past message that the assistant returned to us before returning our before returning the text. And so to update that, I'm going to change our basic agent to our chat agent. And that's restarted. Now, if I say my name is Phil. It's like, hey, hi, Phil. So I've got the temperature turned down, so it kind of tends to respond mostly similarly. But now if I ask it, what is my name? It says your name is Phil. So we have memory simply by storing a list of messages and giving it back to the model. And this is really cool. The fact that we have control over this list of messages also means that over time, as it's getting closer to something like the context limit of the model, we can kind of compact or summarize or extract facts from the messages and just kind of turn it into something a bit more tight if we need to. We can look at that in Langflow as well. I can duck out of my basic agent and go into my memory chatbot. Now we effectively have the same as we had earlier. So you'll recognize that the model, the chat input, the prompt, and the output. Now we've just added a few memory bits around it. And so we can get our message history out of this memory component, which is fed into this prompt. And that's a bit small, but I don't think I can't zoom that, I'm afraid. We have this prompt now that kind of has your helpful assistant that answers questions, but here's your history. And in Langflow prompts, if you surround something in curly braces like that, it becomes a prompt variable. And so that's something you can feed into the prompt from another component. Then on the outside, right, the chat input gets stored. So that's the same as storing the first message from the user, and the chat output also gets stored into that message store. And so we're doing the same thing here. And again, if I go and talk to it, I can say, hi, my name is Phil, and tell me what my name is. I had a fun thing while I was testing this just last week, in which when I asked it to tell me what my name was, one model I think I was actually working with Gemini at the time, and it got concerned for me. It was wondering if I was worried about what other people were calling me, which is really weird because these things don't have feelings. Anyway, as you can see, we're now building.
Are you sure about that?
Well,
I'm just kidding.
I'm going to keep under the impression for right now that they don't have feelings, but I'm also generally polite to them. So now we have this we've built up a bit of flow here. We've got this memory that we've added onto our basic flow, same as we have inside code. Cool. So now we have memory. We still don't have any tools. We've built up the basic bits we need for a chatbot, but not yet an agent. And so let's think about defining tools. I'm going to do a little bit of slides for a bit to show what this means. And here's a function that could be a tool for a model, a function that adds numbers together. I actually think this is a really useful function. It's simple, but language models, whether or not they have feelings or otherwise, are still language models, and they are only kind of generating a probability scape of what the next token can be. And so if they ever try to do arithmetic, they are effectively guessing. I mean, they're effectively guessing everything at this point, but they're right a lot of the time. But when it comes to actual maths, actual arithmetic, there are right answers to these things, not just language. And so giving models like this, something like a calculator, I think is really useful. And so if we defined an add function like this, there's a couple of things to point out about it. Firstly, the parameters here are passed as an object, not as individual arguments. And this is just the way that models pretty much across the board like to return their arguments. They like to start with an object of them. And that's fine. We can handle that. It's easy enough. And then I am returning kind of an object as well. This is all, again, part of the prompt. When you return just a number, the model can probably work out that the number was indeed the result of adding things. But if you tell it this is the addition result, it knows, or it has more chance of knowing, that this number is the result of adding the two numbers it asked for. And so just a little bit of extra prompting there for it. I also like to show the simplest possible piece of code here, because the function definition is more important. Oh, I done added. Do you know what? I forgot to change my slides. All right. Bear with me once. So
we know you meant to say Azure. It's okay.
I meant to say Azure right here. And so this is showing Google Gen AI. What I've actually done here is, well, we can go and look at real code a bit in a minute, but this is still the same idea. So you need a function declaration that has a name, in this case, add a description, adding two numbers together. I also like to tell it to use it for accurate addition because sometimes it doesn't care about accuracy. And then the parameters. Aside from this type schema kind of thing, this is exactly the same as you'd use in Azure OpenAI as well. You have a type, which is an object. It can't be anything else at this base level. That's why the function takes in an object of two numbers earlier. And a description, again, every time we describe something, we're giving the model more opportunity to get it right when it picks it. We tell it that there are required properties, both A and B, and when we're adding two numbers, we require both of them. Then we describe each of those properties as well, giving a type and number and a description, a type and number and description. This whole parameter section is a JSON schema document. The models don't fully implement, I think, JSON schema, which is why you can't give a type of string to the bottom version of it. But JSON schema is at least well known and easy to deal with. And then I'm just going to move on from that code because we'll go look at some real one in a second. But yeah, this is kind of an idea of the loop. We go from our user prompt to asking the model to answer that user prompt. It observes what it knows about the world, which is pretty much its existing messages as a system prompt. It asks itself, have I achieved the goal? Like, can we get the goal out of this and generate a result right now? And if not, it can request to use the tools that has access to. That gives us the ability to run those tools, run the functions, give the results back to the model, at which point it has a new observation on the world. It can make a new plan. And if it's ready to answer, it can go and answer. If it's not ready, it can choose to use more tools. And so we can keep going around in this loop until the model is satisfied that it is ready to answer the question. Now that can go on forever, especially if it doesn't have the right tools to answer the question. And so you can set limits on this, like the number of times you do iterate, or give the model an out in a prompt by telling it if it doesn't know the answer, you can give up. And that's fine for it. But let's go build that tool loop. I think that's a good way to look at it, and I can show you better code that's not Google, and I apologize for that again, but indeed OpenAI stuff, Azure OpenAI. And so let's take this chat agent and copy it and paste it and call it agent this time because it's the real deal agent. And what I'm going to do is take in from those options, we're going to get some tools and we're going to get some tool declarations from the options, tool declarations. Yeah. With those tools and tool declarations, we're going to hand them to our model to give it access to them. Well, actually, we only give it the tool declarations. It asks for tools, and we give it the this.tool declarations. So the model only needs to know the descriptions, the definitions of these tools. We do the running of them. And so we start as we did normally. We push the message in, we get a completion, and I'm just going to change that from const to a let, because this is where the loop is going to go. So we've got while. So beforehand, we would just get message.content or the completion choices message, and then we get the message.content to return. But we need to check to see if the model is asked to use any of the functions, any of the tools. And so this comes in as message.toolcalls. So we'll just check to see if it exists and if it's an array that is longer than 0. And when we have that, we need to go, and this is an array of tool calls. You can pin Azure OpenAI models to just ask for one thing at a time, but I don't know why necessarily you'd do that. So you can allow it to have parallel or ask for multiple tools at any one time. And so when you do, you then have to get responses to all those function calls and hand them back to it. And so what we're going to do is get the responses. And this is where I get a bit JavaScript here, I'm afraid. We're going to promise to all. So these are asynchronous calls that we're going to make. So we have to wrap it all in this big promise. And what we're going to do is take the message.toolCalls, and for each of them, we're going to make a call. We're going to take that call. So we get this call object, and inside of it is a function object. And inside of the function object is the name of the function it wants to call and the arguments. So we're going to get those out. Const name and arguments. And I have to rename arguments args because arguments is a reserved word in JavaScript. But we get that out of the function object there. And so now we have the name and the arguments. We can look up the function in our list of tools that we have and call on it. So the response is, list of tools name args. So we're just taking our list of tools. Oh, sorry, it's an object of tools keyed by the tool name, keyed by the function name. And then we straight up call it with the arguments. Although OpenAI turns those arguments as a JSON document. And so we need to parse them to make it work for our actual application. So we get that response and we return what's actually just another message. So we've seen messages that have the role of user and the role of developer. And any message that comes back from the API has the role of assistant. And in this case, the message we now send in is the role of tool. This kind of just makes it more obvious for the model. This is a response from the tool. The content is, I'm going to JSON to stringify the response that we got there. And we also give it the tool call ID. And so this associates the response for this function with the original request from the model to make this call to this function. And so we get all those responses and what they, oops, did that. And we're going to create ourselves a new completion. We're going to send them back to the model with all the previous messages. So actually, yeah, we are going to take the responses and Copilot trying to get in my way again. This.messages, we're going to just take the messages and concatenate themselves with the responses. So that's all of our existing messages that we've had. So all of our history added with the responses from our functions that we've called for it, that it asked for function calls. So we called those functions, we got the responses, we turned that into an array, added that into the responses messages, and then we're going to make a new call, and we want to give it its tools as well, just in case it wants to go again. Now at this point, we could say that, you got no tools to use, you got to just answer the question. But I want to let it go around the loop. I want to let it make the decision itself. And so we just get a new message now from the result of that. I have to remember, that's it. I always forget this bit. You have to push all of the messages. So this is the original message that we got back from the model, which could have asked for some tool calls. And if it did, we'll push it into an array of messages. We then go and get all the responses to all the tool calls. We turn those into messages. We get a new response from the model. And we turn that into this message, and that goes around the loop. So if it asks for more tool calls, we go around the loop, going through all those tools, calling them, asking the chat completion again, getting a new message, and we go around the loop. And that should be it. And so a quick check on that with our agent. Should be that I can say hello to it and it just, it's still responding to me. That's good. But we don't have any tools yet. And so I have built some tools earlier, so I don't have to spend all morning typing stuff. I'm going to start with a date tool. And so I like date. Date's a nice, easy one. It takes no parameters. It's just going to return the date for today in a ISO format. And this is the date function declaration. So it's actually slightly different to that Google version. The OpenAI or Azure OpenAI ones require a type and the type of function, and then it's a function. Then you get the JSON schema declaration of the function itself with the name and its description. Don't guess the date. I like to tell it these things. You have to. It's all prompt engineering stuff. So this date function declaration and this date function can then be imported over here to use date function declaration and date. And this is our agent, and we're going to go give it some tool declarations. Yep, and some tools. And now, so wait, we should make it show that it can't do the date first. I love asking models what the date is today because they just make stuff up every time. And now it has memory, so it's already answered me. But it thinks it's April 27th. If I was to run that again in a new session, it's now June 7th. It doesn't know, it's just guessing. And that's why we've got to help it out. Help it out. Just to point out as well, actually, I like to, all of my tools in this example have a little log here to say, which says think getting the current date. That just means it's calling the tool, but we should see if I ask it, what is the date today? It should just say it's using the tool. It should say think getting current date, and then it's correct. It is May 28th. It's May 28th, at least for me. It might still be the 27th for you guys. Anyway, it's correct for me. It's in my time zone, so I'm happy with that. And that works out. So we have a nice date. And that was a simple one. Like I said, simple declaration. We could do a slightly more complicated one, like fetching something from the internet. So this is it's still a relatively simple function. It's quite literally just uses JavaScript's built-in fetch function to go fetch a URL. It then uses a HTML to Markdown tool to turn that into from HTML into Markdown, because there's no need to send a bunch of extraneous HTML tags as tokens to the model. We can just send it the text it needs. And then here's the declaration. So again, we wrap this in a type of function and then the function itself. We've got a name, fetch URL, a description, fetch the contents of a URL or browse a website. I can correct this right now. Browse a website. And it takes one parameter in this case, so it still has to be an object, which is the URL. So there's one parameter inside that object that's required, and it is the URL, and it is a type of string, and the description is the URL you're trying to fetch. And so if we go and bring that into here as well, we've got fetch URL and the fetch URL declaration. We just add it to our list of things. So these are just tools that are building up in the capabilities of the model. But we've still got a language model under here, which is quite fun because you can now start asking it stuff where it can make up the answers for you. So if you, for example, I can say, you know, what is Phil Nash? That's me working on GitHub. And normally it decides to make up. There we go. It's actually hit the GitHub URL, the API, sorry, to hit up my repos. And has listed a lot of repos of mine. That's exciting, isn't it? Some of my repositories include. So it made that URL up. I could ask it more accurately, like what are Nash's pinned projects on his GitHub profile. And this time I would expect it to just get the profile URL and see what it can find. So yeah, it's made up the profile URL instead, and can go get me the top 6 my 6 pinned projects: ngrok for VS Code, pwned. Yeah, that's all correct. I can prove that. I should prove that. It's going to got this page. It's going to got these pinned repositories. So yes, straight up correct. And so we've just given it 2 tools right now, and it's able to now go and make up URLs and browse the internet. And it's able to know at least what the current date is. I guess I can kind of ask it. Oh yeah, go for it.
We got. Maybe we missed this, but how does the agent know when to use its tools? Does it just every time, is it calling the tools because it's built into your script, or does it know like, hey, this makes sense versus this doesn't?
Yeah, so it all happens in here. It's because we have given it the tools. Actually, the better thing to do slightly is to give it more of an instruction. So right now, it is actually kind of magic. It doesn't call them every time, not at all. What it's doing is we make a request to the agent with our messages that we've had in the chat so far. We also, as part of that request, we're sending in the declarations, the descriptions of all the tools that the agent has access to. And so each time it makes the choice. It's a little bit like here. So we send it a prompt and all the messages beforehand. We send it all the tools it has access to, and it observes and decides what to do with this information. If it's not ready to answer, if it's not generating a text response to that, it will request to use one or more of the tools. And when it requests to use one or more of the tools, that is where in the code, our message here has a tool calls object on it, or a list, an array of tool calls, and then there'll be more than one of them. At that point, we take all this. So we can actually, let's, for example, let's just have a quick log of message.calls. So I'm just going to log that out. And in this case, if I ask it, what is the date again? Nice and simple. So it's come back and it's got this array of tool calls it would like to make in order to help it answer the question. The type is function. The function is the name date. It has no arguments. And so we're asked, the model is asking us to then call on the date function. We do call the date function. We return it to it. We send it back as a new message, this kind of role-based message here. And that gives the model the information back, at which point it then is capable of, it's achieved the goal. It's got the answer, so it can generate the answer for us. And that's where we get the response, which is just finally just text. So yeah, that's kind of it. There is only slightly more to it in that, like, it's best probably at this point to give it a system instruction that actually describes what it should use its tools for. So we can say you are a helpful assistant. And this just also helps us, helps it to answer things. So you have access to the following tools: a date tool that has the current date and time, a fetch state. Yeah, cool. That's all its tools right now. And so that's going to help it know more of what it has access to. The latest. So if we can make some more stuff up for us, got the latest news headlines from Australia. Cool. So I asked it for the latest news headlines in Australia. It's gone and decided to look up abc.net.au/news, which is the national news broadcaster. And how about that? Politics have changed again today. We had an election a couple of weeks ago, and it's all been a mess recently. A mess for the losing party, at least. Anyway, so again, it's able to create a URL, ask us to call on that URL, and then use the answers based on the response. Cool. I just want to show.
And quick question before you move forward. We got another question.
Yeah.
And I love this question because I think we're going to get a little deeper. Is the tool declaration format specific to GPT-4.1 Mini, or is that defined in the agent API, like the Azure Agent Library or the Google Gen AI Library? I'm wondering how easy it is to swap LLMs given this code.
Yeah, good question. And so I did, if my slides didn't already give it away, I have swapped LLMs from Gemini to OpenAI, or Azure OpenAI in this case, in order to give this talk to you. So this bit inside of the function here, in this example, is the same. It is based on JSON schema, and they are the same between, as far as I've found so far, between Gemini and OpenAI. It's just that OpenAI itself actually wants it wrapped in this extra bit of object that says the type is function, and here is the function. So when I was updating this, I had to change all my declarations to kind of wrap the internal declaration that Gemini was using in this just type of function and function properties. So those are the only differences. I assume that's because that there are other types that you can provide or will be able to provide in the future to OpenAI, whereas Gemini does things in a slightly different order. and has like, so Gemini has built-in tools like Google Search or being able to run code in a sandbox that Google provides. And those tools are provided slightly differently. Whereas I guess OpenAI wants it to be provided in the same way. But so it shouldn't be too difficult to swap things out. But the declaration is indeed mostly the same. That's a great question. Thank you. I mean, I will point out that the agent, the basics of the agent are also the same. Like we still grab our messages, we get a response from the object, from the model. It says it wants to use tools or doesn't want to use tools. And we keep going around that loop until it's run out of tools it wants to use. But the code for it is, again, slightly different. So whilst OpenAI asks for tool calls, I think the Google or Gemini, for example, asks for function calls. And it's all just slightly different. But the underlying idea is the same. And so I will share so this is all in a repository, which is called Let's Build an AI Agent. And the main branch currently is actually is the Gemini version. So I can go and show you the agent. The Gemini version of this does the same thing. It's actually slightly neater code because the Gemini SDK handles keeping the message list itself. And so, yeah, so Gemini itself asks for function calls. And so we look for function calls, not tool calls. And it doesn't wrap everything internally in that function object. We just get the name and arguments out of a call. But it's all mostly the same. If you understand one, you kind of understand them all. What I wanted to show next actually was this is the same thing in Langflow, or almost the same thing in Langflow. Building an agent in Langflow is almost the same. So in this case, if we remember, actually, let's just pop back and look at our memory bot. That was the previous one. So we had just a model here. This is using Azure OpenAI. And we had our input, which was being stored. We had our history, which was being fed back through the prompt into the system message. We have our output, which is also being stored. So this next one is going to do all of those same things. We're just going to change a couple of components and add a couple of tools. So here's the agent. Now the agent object here, the agent component is slightly different. So we were previously using the Azure OpenAI model, but now we want to use an agent. And this agent is set up to use multiple different providers. So I set it here with Azure OpenAI, but it has other ones. That's because the agent logic, again, internally, it's the same. It is, asking to see if it wants to use tools, if it does, call them, if it doesn't, send off the answer. It's doing the same stuff as the code we just wrote, but this is just configuration on the outside. And so we still have our history and our system prompt. We still have our storing of a memory and getting the chat input into the model. But now we just have these over here tools. And so this is similar to the one I built so far. We've got a calculator and a URL. So like I say, I like having a calculator because adding and multiplying is not the normal domain of a language model. And then on the outside, on the other side of things, we still have the output. And so if I go in the playground here, I should be able to say things like, same kind of question, like what are Phil Nash's pinned GitHub repos? And this is a real nice thing about Langflow as well, is that it shows you the thought process of the model as well. The model said, hey, I want to call the URL fetch content tool. I want to do so with these URLs. And we can see its output. If I go and hide that away, you can see it's then gone and come up with the same answer, which is great. And also, I can ask it, maths questions. I like asking it what hard multiplications are. 1, 2, 3, 4 times 5, 6, 7, 8. So it's gone and called on the calculator, in this case, a calculator component to evaluate that and get back 7,006,652, which, as far as I know, is correct. Of course, we're only seeing kind of single tool use calls here. One thing we can try and do, and sometimes this decides to use a calculator, sometimes it just doesn't. Like, we are dealing with a model that has to make these decisions. But if I were to ask what is 100 150, let's say, Australian dollars in US dollars. What I'm hoping it's going to do is go and get an exchange rate, and then using that exchange rate, call the calculator. It didn't call the calculator though, because it's confident in its own abilities. But it went and got an exchange rate API. I really like it if it uses the calculator for that, but sometimes it just does not. Anyway, 1 to 645, not bad. Been pretty low so far recently.
Can you tell it to use the calculator tool?
That's a good point.
I think I've done that before. I was like, hey, in the prompt, if you know it has access to a tool, I believe it should follow that direction.
Let's see. All right, let's hit the URL. It's fetching the content. Now it's using it. You're absolutely right. Yeah, so it's all prompt engineering. We hit the URL. We made up an exchange rate API. We got the latest exchange rate for the US dollar and the Australian dollar. It then executed 150 times 0.645 to get an accurate 96.75 US dollars per 150 Australian. So yes, yeah, I think part of the system prompt is a good way to again try and use that.
Yep.
Use the calculator to perform any arithmetic. If I add that to the system prompt, then hopefully in a new chat, I should just be able to ask it that, and it does it without me having to say so as part of the nope. Okay. There's prompt engineering there to work on, but yeah, there is ways to tell it to do so. You just have to kind of tweak and play around with it. But yeah,
is it because maybe you didn't build the component?
Yeah, possibly.
I only say that because I was literally just doing this, Phil, for a workshop we've got going. So yeah, I feel your pain here.
Yes. I built it this time. It's okay. Yeah, there it is. It has called on both. So yeah, we got our input, fetch content, and then execute the calculator evaluate expression. So yes, use the. So I learned this relatively recently, actually. When we give it tools, we describe those tools, but it's still actually important in the system prompt to say when it should use those tools. And so that's why I kind of telling this one to use the date and the fetch tool for these reasons. In the system prompt, you should describe when and why to use the tools you've given it access to, even if those tools have their own descriptions already. Cool. So yeah, so hopefully you can see building up an agent like this inside Langflow is also relatively straightforward. This was kind of the old bits with our memory, and then we just added these tools and this agent component to use the tools. Cool. If I pop back to the slides, I added some other ones actually. I've got some other tools. Oh, that's a good point. No, it's there are other tools, but now our agent itself has memory and tools. And that brings me to one last thing, which is multi-agent. I've got two last things actually. I've got multi-agent agents. I really like this because multi-agent agents are useful for a couple of reasons. Firstly, we can give individual agents kind of different roles and capabilities. How we describe what an agent does and how it should go about doing it is one part of the system prompt. And then the capabilities, the tools that has access to can also be different. Agents can then be tools for other agents. If we just wrap them up inside a function with a declaration, they're just a tool. And so then one central agent can coordinate whilst others do the work. And it's actually not that much more code. So I have an agent tool over here, which actually uses our agent object, gives it a system instruction to call it a research agent, and gives it the fetch URL tool to go and fetch stuff. And then we just get these two functions, a research tool, which gets a response from our research agent, much in the same way. So this is kind of good because it will actually have its own chat history inside of it, what it's been asked, and then its declaration, which just says you need a query to search the web. And so I can replace our fetch URL tool here with our agent research agent, research tool, and research tool declaration. And then that's the research tool declaration there. It's the research tool. And so we now have a research tool. And this isn't going to meaningfully do anything different because now it's just an agent that has access to the URL tool instead. But if I now say, let's pick it research, the latest headlines, news headlines from Australia. It's thinking about some stuff. Oh, and it fell over. Good stuff. Oh, okay. I know what's happened there. Agent tools, there we go. This is because I don't know what's happened there, and I'm going to skip past it because we are running a little long and there's more exciting things to talk about. So let's get back to that. But agents simply can just be another function. And so this is interesting because, of course, if you've done any kind of optimization of code, you know that setting off loops inside of loops inside of loops is a good way to make things take a lot longer, but is a really useful way to have a single agent coordinate a bunch of stuff going on, and that is useful because they can the different agents can think about different things in different ways. Secondly, OpenAI specifically says that models kind of shouldn't get more than 20 or so tools at a time because that can confuse them after that. I think Google and Gemini actually point out like 20 to 30 tools. I feel like Claude and Anthropic have options for more than that, but I don't know what the number is. But basically there's an upper limit to how many tools a single model call can juggle and decide what to use between. But if one of your tools is a model that has an agent that has access to a whole different array of tools and a different personality, that really opens up a lot of opportunity. And then there's MCP. You've probably heard about MCP recently, the old Model Context Protocol. This was invented by Anthropic as an open standard last year to allow for people to provide tools effectively to agents without you having to write all of your own yourself. It's a standardized protocol for agents to interact with services. And it comes as two parts. We have a server, and an MCP server makes available resources, which are effectively sort of static-ish responses. Then there's tools, which they define more as things that are going to change something. So if you were going to compare this to HTTP, for example, static or resources would be like a GET request, whereas tools are more of a POST request. And then there are prompts, which I think are just there to help an MCP server help an agent ask it things. I've not seen those used very well yet so far. And then on the other side, there are clients. So initially, this was things like Claude Desktop or Cursor are MCP clients, and they interact with servers on behalf of an agent. But the MCP JavaScript tooling and I believe it's other language kind of tooling gives you things to build servers with, but also clients. So we can include clients inside of our agent as well. And so I did that already. What have I got? I've got this MCP thing here, and I've had them hidden away because MCP servers are actual servers that you have to start up and run. I didn't want them getting in the way of our stuff. But I have two MCP servers here. I have a calculator. I've been talking about calculators for a little bit at this point. But instead of me implementing my own calculator, I have an MCP server, which is going to do stuff for me. And so we set up a transport for that for that server. MCP servers can talk over kind of they can talk over standard input and output or over HTTP. And the HTTP version has been changing slightly as they evolve the model, but this is just going to work over input and output right now. We give it the command and the arguments to start up the server. And so in this case, it's using UVX. So it's running it's a Python server and the MCP server calculator. We then create a client to talk to it. We connect the client to the server and we extract the tool declarations from it. So you call on the calculator to list its tools. And then I do have to do a little bit of massaging of that into what the Azure OpenAI API wants. And so there's just a function down here that kind of strips out things that aren't going to be used and then returns this object with the function, the tool name, the description, and the parameters that it expects. And so I've done that for that, and then we just take those tool declarations and turn them into functions that are going to call the server. So we have this client that calls a tool based on its name and its arguments. I've done that for a client. I've also done that for Tavily. Tavily is a search API, which is really useful for this kind of stuff. And so I can go and import those via the MCP clients. So what did I say? Calculator, tool declarations, calculator tools. Let's get the Tavily ones. Cool. And then I can just use them as tool declarations. They may well declare more than one tool though, so I do have to spread this out. So let's go, calculator tool declarations and Tavily tool declarations. So I've got date. I can actually drop the fetch one again because Tavily is going to be a better experience than just calling a URL. And again, I'm just going to spread out the things there. I know specifically that Tavily has more than one tool. But the calculator tools also come as a object of objects as well. And so now I have an agent that has access to 2 MCP servers that can calculate things and search the web. And so actually this is a good time to try and get it to, oops, you have a, need to update its search tool and calculator tool, cool. Update its system prompt. And let's see if we can get this tool to do exchange rate calculations as well, using more than one tool. And in this case, those tools all over MCP. So what is the value of 150 AUD in USD? So it's done a search. It's gone and searched for 150 AUD to SUD. Of course, it's doing a search response. So it actually goes and figures it out itself. If we'd just given it the fetch tool, it might have just made up the URL. It's always fun to find out what these things are doing. Anyway, what we did there was we searched the web, and it came back with a response. It was a little bit off according to our other responses, but let's just make it do some maths as well. Tell me what the square root of I like to do something I know first. So it's kind of got square root of, yeah, cool. So it called the calculator with an expression of squirt 144. That little Python calculator was happy to go off and do its job. If we then give it something just to make sure it's not guessing or coming out like, ooh, okay, 38.6 is the square root of 1490. I don't know if I have a calculator on hand to check that, but I believe it. So cool. So MCP servers are something you can build into your agents with not a lot of code themselves. And they are just tools that access the tools that are accessed over a transport rather than functions just directly inside your application. And so that's what I want to show you today. Building an agent kind of is very, in a straightforward way, is just building that loop of give it functions that it can call, or give it descriptions of functions it can call, and a task to achieve. Wait to find out if it's calling on those functions, call the functions for it, give it back the answer. See if it wants to call functions again. If it does, call the functions, give it the answer. If it doesn't, we're done and it's generated a response. That is an agent. When you build up multiple agent systems, because those agents are just tools to each other, they can have different personalities, different roles, different ways of going about achieving goals. That is where we build up powerful and interesting systems. This code today is probably not production ready, and there are a bunch of frameworks out there that will make things easier for you. Langflow is absolutely one of them. It allows you to both experiment quickly with drag and drop, but also has that agent built right into it. But also go check out all of the other available things. Go check out Copilot agents for your low code version of it, or the Azure AI Foundry agents, where you can build Azure functions into it. But go build with them. I'm so excited to see what everyone's going to build here. I would say that, like, don't go out there and try and build a super agent that's going to achieve everything. because people already have their desktop agents that are doing that. It's upon us to build agents that are going to be useful for our customers and our businesses, using tools, using APIs within our own value that we already provide, that are going to make things easier for users using our systems. And so I can't wait to see what everybody does build. Thank you so much. Again, I said that all that code is online on my GitHub. I can share the link in the chat in just a second. But again, my name is Nash. I'm a developer relations engineer at DataStax, and it's been an absolute pleasure to talk to you this morning. Thank you.
You rock, Phil. Now, before we go to Q&A, I would love if everybody could come off mute, turn their camera on. Let's give Phil a virtual round of applause, good sir. Thank you from across the pond.